Hello, everyone. Today, we're diving into a really important chapter for your exams, areas related to circles. We're going to focus on how to calculate the area of sectors and segments. Now, I know it can sound a bit tricky at first, but trust me, we'll break it down so it becomes super clear and simple.
So here's our game plan. We'll start with the absolute basics, then we'll get into the key formulas you need. After that, we'll tackle a problem together, step by step, and we'll finish up with a quick recap and some really important exam tips. Ready? Let's get started. All right, first things first, let's make sure we're all on the same page about what we're even talking about. We're going to start with the simple, foundational ideas of sectors and segments.
You know, the easiest way to remember this is to think about a pizza. Seriously. As you can see on the left, a sector is just like a slice of pizza. It's the area between two radii, those are the lines from the center to the edge, and that curvy outer edge, which we call an arc. Now, look to the right. A segment is like just the crust part of that slice, the part you'd get if you cut it off with a straight line, which in math we call a chord.
So to put that in proper math language, the formal definition is a sector is the portion of a circular region that's enclosed by two radii and the arc that connects them. The smaller slice is called the minor sector. And you guessed it, the huge remaining part of the circle is the major sector. And for a segment, the official definition is the part of the circle that's enclosed between a chord and its arc. And just like before, the smaller piece is the minor segment and the bigger piece is the major segment. Simple, right? All right, so now that we know what sectors and segments are, let's get to the fun part, figuring out how to measure them. These formulas are basically your secret weapons for solving any problem in this chapter.
So here's the big question. We all know how to find the area of a whole circle, but how on earth do we find the area of just one little piece of it? Well, let's look at the logic. It's actually pretty cool.
Now, this is a common tricky point, so let's walk through this carefully. It's all about logic. We know a full circle has 360 degrees, and its area is pi r squared. So if we want the area of a tiny sliver that's just 1 degree wide, what do? We just divide the total area by 360. Then, to find the area for whatever angle our sector has, let's call it theta, we just multiply that 1 degree area by our angle, theta. See? It's not magic, it just makes sense. And that simple logic gives us our big, important formula. The area of a sector is just the angle, theta, divided by 360, all multiplied by the area of the whole circle, pi r squared. This is the first formula you absolutely need to remember. And you know what's really neat? We can use the exact same thinking to find the length of the arc. That's the curvy crust part of our pizza slice. This time, instead of this circle's area, we just start with its circumference, which is 2 pi r. So the formula looks almost the same. Theta over 360 multiplied by 2 pi r.
Okay, enough with the theory. The best way to learn math is by actually doing it. So let's walk through an example together, nice and slow, step by step, to see how these formulas really work. Don't worry, you've got this.
Okay, here's our problem straight from your textbook. We need to find the area of a sector that has a radius of 4 centimeters and an angle of 30 degrees. And then, as a part 2, we need to find the area of the big corresponding major sector. And here's a little diagram so we can see what we're dealing with. Our job is to find the area of that shaded piece, the minor sector, which is labeled OAB.
Step 1, and this is always step 1, is to write down what we know. The problem gives us 2 key pieces of information. Our radius r is 4 centimeters, and our angle theta is 30 degrees. Step 2, write down the formula you're going to use. This is such a good habit, trust me. It helps you remember the formula, and more importantly, it stops you from making silly mistakes. We need the area of the sector, so let's write down that formula. Now for the fun part. We just plug in the numbers we have into our formula. So we'll replace theta with 30, pi with 3.14, just like the question asked, and r with 4. Easy. And now we just have to do the calculation. Let's simplify first. 30 divided by 360 is the same as 1 over 12. And 4 squared is 16. So our equation is now 1/12 times 3.14 times 16. You crunch those numbers and you get our answer, approximately 4.19 square centimeters. But wait, we're not done yet. Remember, the question also asked for the area of the major sector. Now, the easiest way to find this is to first find the area of the entire circle and then just subtract the little piece, the minor sector that we just found. The total area is 50.24, and when we take away our 4.19, we're left with 46.05 square centimeters. And there we have it, our final answers.
The minor sector is about 4.19 centimeters squared, and the major sector, after we round it a bit, is about 46.1 centimeters squared. See? Not so scary after all. You did a great job following along. You've got a circle, and its radius is 21 centimeters. Now, a chord cuts across it, and it carves out this shaded area. That's what we call a segment. And the angle right at the center of this segment, it's 120 degrees. So the million-dollar question is, how do we figure out the area of just that shaded part? So here's how we're going to tackle this. First, we need to get a really clear idea of what we're aiming for, the segment itself. Then we're going to find the area of the whole pizza slice that it's a part of. That's the sector. After that, we'll calculate the area of the triangle that we need to get rid of. And finally, we'll put it all together to get our answer. Oh, and we'll even take a quick look at the other side of the circle too. Let's do this. Okay, so first things first, what exactly is this shape we're even trying to measure? So yeah, what is a segment? Well, it's pretty simple, really. It's just that area that gets trapped between a chord, that straight line cutting through the circle, and the curved edge, which we call an arc. Our whole mission here is to find the exact size of that little region. Now, you can't really measure the segment directly, it's just not a standard shape. So our strategy, we're going to start with a bigger, much simpler shape that actually has our segment inside it. And that shape is called a sector. And what's a sector? It's the piece of the circle held between two radii and the arc that connects them. Honestly, the best way to picture it, it's a slice of pizza. It's that simple. And our little segment is sitting right there inside this slice. So if we can figure out the area of the whole slice, we're a huge step closer to our answer. And the formula for this? It's actually super intuitive. You're basically just finding out what fraction of the whole pizza, circle, your slice is. You just take the angle of the sector, which we call theta, divided by the full 360 degrees in a circle, and then you multiply that fraction by the circle's total area, pi r squared. Easy enough, right? Okay, time to plug in our numbers. So our angle is 120 degrees, the radius is 21 centimeters, and we're just going to use 22 over 7 for pi here. Now, that fraction, 120 over 360, that simplifies really nicely down to just 1/3. So all we're really doing is calculating 1/3 of the area of the entire circle. And when you run the numbers, boom, we get our first key piece of the puzzle. The total area of our pizza slice, that's sector OAB, is 462 square centimeters. Awesome. Step 1 is officially done. All right, so we've got the area of the whole pizza slice. But remember, we only want that little curved segment part. That means we have to subtract the area of that triangular piece, OAB. Okay, now figuring out this triangle's area, this is where the clever part comes in. See, it's not a right-angled triangle, so we can't just throw the standard formula at it easily. So, what do? We use a neat little geometric trick. We're going to draw a line straight down from the center, O, to the chord AB, so that it hits it at a perfect right angle. Let's just call that point where they meet M. This one little line, it is the key to this entire problem. What it does is it splits our weird, tricky triangle into two perfectly identical or congruent right-angled triangles. And because they're identical, it also slices our 120-degree angle right in half, which gives us two nice, neat 60-degree angles. And just like that, we've got simple right-angled triangles to play with. And you know what that means? We can bring in our old friends from trigonometry, sine and cosine. So let's use these brand new right-angle triangles to find the height and the base of our original triangle. For the height, that line OM, we're going to use cosine. Cosine of 60 degrees gives us OM over 21, which works out to a height of 10.5 centimeters. Nice. Now for the base, we'll use sine to find just half of it. That's AM. Then we just double that to get the full base length, which comes out to 21 times the square root of 3. Okay, now we have the base and we have the height. So we can finally use that classic formula for the area of a triangle. 1/2 times base times height. We just have to pop in the values we just found. And that gives us the area of our triangle. 441 times the square root of 3, all over 4 in square centimeters. And with that, step 2 is done. We've got both of our building blocks now. All right, the hard work is over. Seriously, we found the area of the big pizza slice, and we found the area of the triangle we need to subtract. This final step, it's beautifully simple. The logic here is as simple as it gets. The area of our segment is just the area of the sector minus the area of the triangle. It's the whole piece minus the part we don't want. That's it.
So all we do is take our first number, 462, and we subtract our second number, that 441, times the square root of 3 over 4, and that's it. That is the exact area of our shaded segment. Puzzle solved.
But hang on a second. Whenever you slice a circle with a chord, you don't just make one segment. You actually make two. We just found the area of the smaller one, which is called the minor segment. So what about the rest of the circle? Yeah, you've got the minor segment, the smaller piece, and the major segment, which is the big one. And the great news is, to find the area of that major segment, you absolutely do not have to go through all those calculations again. Thank goodness, right? There's a way easier way to do it. The shortcut is just, it's perfect. All you have to do is calculate the area of the entire circle, pi r squared, and then just subtract the area of the minor segment that we already found. It's the whole circle minus the little piece, and that leaves you with the big piece. Super simple and really effective. Let's do a super quick recap of everything we've learned, and then I'm going to share a really crucial tip that'll save you marks in your exams. So here are the 3 key formulas you absolutely have to know. The one for the length of an arc, the one for the area of a sector, and the one for the area of a segment, which remember you find by taking the area of the whole sector and subtracting the area of that triangle inside it. Honestly, this is a great slide to take a screenshot of for your revision notes. And here is my exam tip for you. Please, please, please be careful and don't mix up the formula for the area of a sector with the one for the length of an arc. It is such a common mistake. Just remember, area uses pi r squared and length uses 2 pi r. Always double check what the question is actually asking for.